This video is about the differences between compilation and interpretation. Now, compilation is a process of generating some low-level code from a higher-level representation of a program, which is usually the source code of the program. And if there's no error in the program, the output of compilation is either the machine code, which would run directly on a computer, or some intermediate representation of that code, which is one step closer to the machine level code. So there would always be an output file in a compilation process. Now, interpretation means to parse the input and immediately execute the output without actually creating some output file. Now, Java is a language which is both compiled as well as interpreted. Java code is first compiled into the bytecode using the Java compiler, and then this bytecode is interpreted by JVM to actually create some machine level code which would actually execute on the computer. Now, this approach of having some intermediate representation has two specific advantages. First is that it would allow Java program to be platform independent, because this intermediate code would not depend on the underlying architecture of the computer. And secondly, suppose a program has to run on a system umpteen times, then in order to run the program, that program has to be converted to bytecode only once, and then that many times only this bytecode need to be interpreted to actual machine level code, which would be faster than achieving the same machine level code from the source code every time one needs to run the program. Now, any language can be compiled as well as interpreted. It's the decision of the language creator which path they want to follow or combine both approaches, as in the case of Java. But there's one other important difference between compilation and interpretation, and I would like to show that using a program. Now, to show how compilation works, I will deliberately add some compile time errors into the program. Now here I have assigned a parent class object to a child class reference, which is bound to cause a compile time error. And in the next line, I'm trying to print the value of j in spite of the fact that I have never actually declared what j is. Now I will save this and I will compile it. Now notice here that while compiling, the compiler will give me a description of all the errors in the program. Now I will remove these compile time errors and change the statements which would cause a runtime error. Now here in this statement, while downcasting the parent class object to the child class, I am deliberately telling to the compiler that I know what I am doing here, so that it would not cause a compile time error on this statement. And in the next line, I have declared the value of j, but deliberately I am trying to create a divide by zero error here, which should show at runtime. But see what happens, this code will compile fine, and it would create some class files which are just intermediate representation of this code. But when I will run this code, JVM will give me a class cast exception here, but JVM will not give me any error regarding this divide by zero. So now it should be clear that while compiling, the file is scanned first and then converted. So if there's any error in the source file, all of them would be visible to the compiler. But in case of interpretation, as it works line by line, interpreter will be aware of only the first error and it will not show any warning regarding the subsequent errors. And this difference is only because of how interpretation and compilation works. And that would be all. Thanks for watching.